Hi, this is HyeonBeom from Wonderlab in ID Heist, and I introduced the Scienscope handheld mediation device for facilitating exploratory behaviors with exhibits in museum visitors. Several devices are now widely utilized to avoid boring method of information delivery. The museums provide mediation devices such as audio guides, kiosks, smartphones, and tablets that motivate visitors to induce exploratory behavior with additional information. Those channels can increase the interactivity of exhibits, and visitors can explore plenty of information in an interesting way. However, the interactions, in fact, mostly occurred on the display of the devices, where are not the actual exhibit, so it occurs lure of the screen issue. So the display distracts visitors' attentional focus from the exhibits, and it decreases engagement with the actual exhibits and motivation to explore them. As one of the possible solutions suggested by Russell and Mayer, many researchers designed some devices with look-like magic lenses so that the visitors can see the exhibits through the screen. However, the strategies do not completely solve the lure of the screen issue because still the interactions take place in a distance from exhibits. So this research started with the question, how about the user can interact with exhibits through the mediation device in a close distance? Starting with the expert interviews, we could understand design issues about interactive devices in museums and got inspiration for the design of a new mediation device. And to generate ideas, we've conducted bodystorming in actual museum. The generated ideas were converted to 3 design features. Based on that, we developed concept of prototype that diverged possible interaction scenarios through storyboarding. 3 museum experts were recruited for the interviews to understand how museum visitors enjoy the exhibits and how new interactive technologies are accepted. Each expert charged on directing the exhibits and guiding visitors so we could get their insights regarding museum visitors. The 15-minute semi-structured interviews were conducted in each museum while they guiding us and explaining about the exhibits. We could organize the interview results into 3 findings. The experts' the biggest concern was visitors' short interest in the exhibits. Visitors easily lose their attention with long texts, especially when exhibits located in the show window. Visitors prefer touchable objects rather than reading texts and images far from the actual exhibits. Also, there are really various visitors with various age, expertise, and interests. Interactive technologies were usually used to satisfy them. While in interviews, we could find many open samples which can satisfy the visitor's needs for tangible interaction. Not only those optical tools like magnifier, the interviewees mentioned diverse tools for observing the exhibits and nature. So we got the inspiration for this design process, right? The observing tools can provide additional information while exploring exhibits in close. We believe that the behavioral metaphor of those tools could be an intuitive and natural interaction for providing information on the surface of exhibits. So we chose the bodystorming method to testify our initial idea. We picked some analog observing tools and brought it to the actual museums, then acted out an observing experience with them. We imagined new interactions that can be triggered by observing behaviors and how additional information can be popped up. Total 42 ideas were noted on the Polaroid pictures. And through the Affinity Diagramming session, the ideas were converted to 3 design features. Most of our ideas were generated from the stethoscope and magnifying glasses. We expected that the tools observing behavior, moving horizontally over the surface of exhibits, can provide physical exploratory behaviors. Also, while using the tools, if it can provide zoom in and out or seeing through the exhibits, it could be a way of allowing visitors to navigate multiple layered information. Finally, the ideas could be integrated to use the multimodal feedbacks. For example, if the fossil can provide roaring sound through the magnifier while observing, it could be impressive. We named the concept of new mediation device as Scienscope. It can be moved on the surface of various exhibits. The additional information can be displayed over the showcase of exhibits, so the information and related parts of the exhibit can be aligned. Also, it can provide see-through and magnifying metaphors to blur the boundary between exhibits and virtual images. Not only the images, but also visitors can selectively find more information while hovering Scienscope over the surface. Finally, we added the lens for instant immersive experience. It was inspired from the binoculars. For drawing the detailed functions of Scienscope and requirements, we conducted storyboarding like the figure. Hardware components like the joystick to manipulate the information were decided through this process. Then, through rough prototyping, we decided size and form of the grip, and the electrical components were integrated into the aluminum case. Scienscope consists of a small smartphone for computing and display. The PCB boards deliver the sensor's value. The sensor board identifies the exhibit with RFID chips. The mouse sensor and distance sensor detects movement over the surface. Also, the audio and haptic module produces the multimodal feedback on the grip. On the top part of the case, the motoscopic lens can be attached with magnets, and the joystick can be used for navigating the information space. 3 applications were implemented to show how Scienscope can be used. The first application used a panel with human body. When Scienscope is placed on the both part, human body's blood vessels appeared. User can move it following the body. Scienscope provides the audio-haptic feedback of the heartbeat, and it becomes smaller as far from the heart. Second application shows how Scienscope can interact with open samples. The small stroke engine module has RFID tag, so when Scienscope is placed on it, the display shows what happened in the real stroke engine. In this case, also the audio and haptic feedbacks are synchronized so user can feel the realistic engine sound and vibration on the hand. Third application shows how Scienscope can interact with an exhibit in the showcase. There are multiple tags around the showcase, and each has different perspectives on the contents in various ways. Also, user can move the joystick to pop up more detailed information. The lens cap can be used to look around the inside of the architecture. Together, the museum visitors feedback, we held 3-day exhibition in Geological Museum. Total of 33 groups of visitors have come and used Scienscope with the application. We observed the users' behavior and responses. After their viewing, we asked the questions through an interview lasting between 10 to 15 minutes. The result could be converged into 3 findings. First, the different users' ages led to different understanding level. While the younger visitors use only surface tracking or playing videos, the older visitors tried to fully explore the information layer. One of the interesting points was that visitors tried to place the Scienscope on the other exhibits, which we didn't set up. It seems because we hid the text in simple stickers, so they felt curious about what appeared in the other exhibits. Especially for the children, we could observe they wanted to use it themselves without parents' help, and it seems because of the rich multisensory feedback and intuitive interactions of Scienscope. Based on the whole design process from the expert interview to preliminary user study, we discussed what we learned and expectation for the future work. Through this prototype, we were able to see the possibility of novel interaction design by narrowing down the distance between the mediation device and exhibits. It helped the visitors keep their attentional focus on exhibits by providing additional information based on the visitors' exploration on the exhibit surfaces. Because of the physical metaphors like zoom in and out or magnifying the surface, it seems to be more effective than traditional display tactics in interpreting how the exhibits and additional information are related physically. We are expecting that this interaction with authentic exhibits like real fossils will be more impressive for visitors. The visitors compared the experience to a treasure hunt inside the exhibit and gave us positive feedback. Although we didn't conduct a quantitative evaluation, it seems that curiosity was the motivation of the exploratory behaviors of visitors, what we observed. In future work, more specific research will be needed to uncover how the information can be hidden, the extent of curiosity, and the impact on the museum experience. Scienscope provided relatively simple content, but visitors from different age groups enjoyed interactions in the desired information layer. Thus, if more layers of information are designed in the content, it is expected to satisfy multiple types of visitors. The complexity of the content should be designed with caution at the same time. For example, more eye-catching simple contents would be better for the shallow layers, and more informatics images or texts would be better for the deeper layers. So thank you for listening, and this is the end of the presentation. Thank you.